Okay, today we will be talking about similar polygons, and if we remember what a polygon is a closed figure with no curves. Remember, that's the generic Mr. Guerrero definition. Your basic triangles, rectangles, squares, parallelograms, pentagons, hexagons, all that good stuff. We'll look at what the word similar means here in a moment. Alright, so similar, it has a two-part definition, much like we did with polygon. Shapes are similar if one, so I'm going to write one. Similar means two things. The first thing similar shapes must have is corresponding angles are congruent. So they have to have corresponding. We'll redefine corresponding here in a minute. Corresponding angles are congruent. Now I'm going to use the congruent symbol, which is the equals with the squiggle. Now if you remember what congruent means, congruent just means, hey, they're exactly the same. That's the first part of the definition. So we have to check for that first. Now the second part of the definition is that corresponding, there's that word again. And what corresponding means is just that, hey, it's in the same position. So corresponding side lengths are proportional. Now we worked with proportions last class. What you have to remember about proportions or proportional is simply this, that if you have a fraction of 2/4, that is equal to 1/2. That right there is a proportion, saying, hey, this fraction is the same as this fraction. Now that's our two-part definition of what similar shapes, similar polygons are. You have to have one, corresponding angles. So angles that are in the same position, that's what corresponding means. Angles that are in the same position are congruent. And then corresponding side lengths, so side lengths that are in the same position are proportional, meaning that the ratios of corresponding side lengths are the same. Right. Let's backtrack. Let's go back to this slide now. Now what we're looking at here is we have two, they're quadrilaterals, they're polygons, they're quadrilaterals. But if we look at these shapes could also be specifically defined as being a right trapezoid. A right trapezoid. So what we're going to do, first off, shapes are similar, corresponding angles are congruent, we know that, and corresponding side lengths are proportional. We'll look at that more here in a second. Alright, so are these two shapes similar is what the first question asks. Hey, are these two right trapezoids, are they similar? And then it says write a similarity statement, which we'll get to that here in a minute, and a statement of proportionality. Alright? And then what is the magnitude? We'll get to all that stuff here in a second. Now the first thing it says, remember that first part is corresponding angles are congruent. So we need to check this first part here. That was the number one that we wrote on the other side. So let's go to A. Now here's what corresponding means. Corresponding means in the same position. So if we look at angle A here, what angle over here on this bigger guy is in the same position? Well, that would be E. Those two guys are corresponding angles, meaning they lie in the same position. Are they congruent? 90-90, you betcha. Well, let's go to B. What angle is corresponding to B over here? Well, that would be F. Okay. Are those corresponding angles the same? Well, you betcha, they are. All right, let's go to C, and G would be corresponding angles. Are they the same? Yes. And then D and H are corresponding angles, and they are congruent as well. So are our corresponding angles congruent? Yes. That's our first check. But now we have to go to the second part of that definition, and this is the tricky part. Corresponding side lengths are proportional. Okay, so I'm going to erase all the scratchings I just made now. Now we're worried about side lengths. Okay. So let's go to the first side length. Now what I'm going to do, guys, is we're going to write a ratio here of sides. Now what I'm going to do is I'm going to start with a smaller shape and put it in the numerator. So if we look at 4 right here, go over to this shape over here. What side length is corresponding to that 4? Well, it's 6. So what I'm going to do is I'm going to put 4 over 6. Now that's a ratio of corresponding sides. Okay. We just took 4, I took the small shape, put it on top, and that's what I'm going to always do for consistency's sake, is always take the side length from the small shape and put it in the numerator. Now, those should be proportional. That means those fractions should be equal to each other. So what we're looking at now, let's jump up to this 6. Look over to this shape. What side's corresponding to that 6? Well, that 9 is. So I'm going to put 6 up top because it's on the small shape over 9. Now let's run this out. We have 5 and 7.5. And then we also have 5 again and 7.5. Now I hope you can tell right here that these last two fractions are equal. Alright, well 5 over 7.5 is going to equal 5 over 7.5, duh. Alright, but what we need to look at is, are these equal to the other two? Well, let's go ahead and simplify these guys. What does 4, 6 simplify to? Well, 2 goes into 4 2 times, 2 goes into 6 3 times. And that simplifies to 2/3. Let's look at 6, 9. 3 goes into 6 2 times, 3 goes into 9 3 times. Now your calculator probably won't do this for you, but if you took 5 divided by 7.5, you would get 0.66666. And I hope you kind of recognize that decimal. If you would put that as a fraction, it would be 2/3 as well. And so would that. Alright. Well, now what we need to look for is for these guys to be proportional. For these two shapes to be similar, these ratios of corresponding sides need to be proportional, meaning they need to be equal. So is 2/3 equal to 2/3 equal to 2/3 equal to 2/3? Well, yes, it is. Okay. So there's our check 2. The corresponding angles were congruent, and then the corresponding side lengths are proportional, meaning the ratio of corresponding sides are all equal. So are these two shapes similar? We say yes, they are. Yes, they are. And we proved it right down here. Here's our proof of why. So those corresponding side lengths are proportional. Now, what we want to do is we want to write a similarity statement. That means, hey, this shape is similar to this shape. Now, how we do that is very simple. Let's name this little guy. Now, the little guy, I'm going to go ahead and start at A, and I'm going to go right around the horn and call it A, B, C, D. So I'm going to say, hey, A, B, C, D. We've done that before. Not for a while, but we've done it before. Now, here's the new one. Is similar to. That squiggle, just the one squiggle right there means it's similar to. It's not congruent. That's congruent. That means it's exactly the same. Similar does not mean it's exactly the same. Similar means it's got corresponding angles that are congruent and the sides are proportional, but it's like twice as big, 3 times as big. Now, since I started at A here, I have to start at the corresponding angle, which would be E. And then I went up to get B, so F, so it should be E, F, G, A. Now, if you look at the way I named that, A and E were corresponding, B and F were corresponding, C and G were corresponding, and then D and H. That's how we need to name it, in proper order. All right, so this is our similarity statement right here. We're going to be doing some of that today. Similarity statement. That says, hey, this shape is similar to this shape. A, B, C, D is similar to E, F, G, H. All right, now, the next thing it asks for is, what's the statement of proportionality? We've already done that. This thing right down here, either one of these is our statement of proportionality. Statement of proportionality. So we're done with that already, and that's one of the first things we do. Well, we check the angles. We check the angles first, and then we do our statement of proportionality to see if these shapes are similar. And in this case, we found that they were. Now, the last thing I ask here is, what is the magnitude? Now, another name that we're going to use for that is called scale factor. And all the magnitude is, or the scale factor is how many times bigger or smaller something is than a similar shape. So we actually already have the scale factor here. Now, or the magnitude. Now, the letter we use for magnitude and scale factor for some reason is K. Now, I'm not sure why, but that's just mathematically what we do. The scale factor here, you might be able to guess what it is right down here. That's our 2/3. Okay. Now, what the scale factor means is that this guy, this little guy right here, is 2/3 the size of the big guy. Now, what you could look at is if you took 9 times 2/3, you'd be sitting at 6. If you took 6 times 2/3, you'd get 4. If you took 7.5 times 2/3, take a while and guess at what you get 5. All right. Now, that's the scale factor going from big to small. Big to small. The small guy is 2/3 the size of the big guy. We also have another scale factor here. Now, if you think a little bit, going from big to small would be 2/3. but going from small to big would be 3/2. Now notice what I did. I just reciprocated that, flipped it over. So when you have one scale factor, you actually have two. It just depends on which way you are going. Now if I would go 4 times 3/2, 4 times 3/2, I would get right back to 6. If I took 6 times 3/2, I would get 9. Okay. Now if you think of 3/2 as a decimal, that's 1.5. That means that the big guy is 1.5 times bigger than the small guy, all the side lengths. Now notice the angles stay the same. The angles won't change because we still have to have 360 degrees there in those quadrilaterals. So the angles will not change. But the side lengths are 3/2 times bigger or 2/3 times bigger. Now, if you didn't draw that first one, I would suggest you draw this one, and you can pause it now, and you can sketch it on your own, and then replay it when you're ready to go. All right, now I'm going to go ahead and go. Are the triangles similar? Show y and find the magnitude. We're also going to write a similarity statement here. Okay. So let's go see if these two guys are similar. Now, the first thing we need to do is go ahead and check the first one. Now the first check we had to do was, are my corresponding angles congruent? That's what we need to do first. So let's go look at A. Here's angle A. Its corresponding angle would be angle D. Are they congruent? Is 53 congruent to 53? You betcha. Go to B. Its corresponding angle would be E. Are those two congruent? 37 and 37? You betcha. I'm also going to draw those arc marks to show that they're congruent. And then 90 and 90 are congruent as well. So we checked one. Corresponding angles are congruent. Now we need to go check the second part of that. The second part was that corresponding side lengths are proportional. So let's go check that. And to do that, I'm going to start with this 3. Remember, I'm always going to put the smaller shape in the numerator. So we'll go 3 over, look at its corresponding side, which would be 6, 3 over 6. Let's check to see if that's proportional. So that's equal to, let's go to the 5 over 10. And notice that's that 3, 4, 5 right triangle we see over and over again. And then 4 over 8, its corresponding side. And notice I put these small side lengths on top every time. All right, let's go ahead and do this. Are these proportional? Meaning, are these fractions equal? 3/6 simplifies to 1/2. 5/10 simplifies to 1/2. So those two are. 4/8 simplifies to 1/2. So all the side lengths are proportional. So corresponding angles are congruent. Side lengths are proportional. Side lengths are proportional. So yes, these guys are similar. Yes, they are similar. Now, we did this right here. Remember, this is the statement of proportionality. You do not need to write statement of proportionality, but you do have to actually write the numbers out. This is what I would expect with you. Okay. But that's the statement of proportionality. So yes, they are. Let's write a similarity statement. Let's call that guy triangle A, B, C. Similar to, meaning our squiggle, triangle. Now remember, what sides correspond, or what angle is corresponding to A would be D, so we have to start at D. B was second. Its corresponding angle was E, D, E, F. That's our similarity statement. So if they ask you to write a similarity statement, that's what I want. Saying, hey, this shape is similar to this shape. All right. Now the last thing we need to do is let's go ahead and find our magnitude, which we already have it. The magnitude, aka scale factor, is 1/2, or reciprocate that would be 2 over 1 or 2. Now what that means, depending upon which way you go, if you go from small to big, your scale factor is 2. Because this guy, everything on this guy over here is twice as big, except for the angles. The angles stay the same. 3 times 2 is 6. 5 times 2 is 10. 4 times 2 is 8. Now, if you go backwards, if you go from the big guy to the small guy, the scale factor is going to be 1/2. Meaning 6 times 1/2 is 3, 8 times 1/2 is 4, so on and so forth. So that's how that works. So you actually have 2 scale factors. And we found those over here with our statement of proportionality. And then this is our similarity statement. All right. Moving on. Are the shapes similar? So again, we need to check the first thing. The first thing, are corresponding angles congruent? So let's look at angle A. This angle right here. Now the corresponding angle would probably be W. Are those angles congruent? No, they're not. Are these angles congruent? No, they're not. So could these shapes possibly be similar? No. Now, if I asked you to explain that, you would simply say, well, corresponding angles are not congruent. So that would be your explanation of it. Corresponding angles are not congruent. All right. Next one. Are the shapes similar? Show why. So we need to check the first thing. The first thing we need to check, are my corresponding angles congruent? So let's look at A. What angle over here would be congruent to A? Well, F would. And are they congruent? Yes, because they are one arc mark, one arc mark. We haven't seen those for a while, but that means that, hey, this angle is congruent to this angle. So those are. Let's go to B. Would be G. Are those angles congruent? Two arc marks, two arc marks? Yes. Angle C, three arc marks. Angle H, three arc marks? Yes. D and I, yes. E and J, 100, 100. So yes. So we checked one. Corresponding angles are congruent. Now the next thing we need to look at is, are the corresponding side lengths proportional? This is where we do our statement of proportionality. Right? So we're going to start that. So we need to look at what sides are corresponding. I'm going to start right here at AB. Now let's look at its corresponding side length. It would be 7. Now remember, I said always, just for consistency's sake, let's put the smaller one on top. So let's go 7 over 10.5 equals, we go right around the horn, 8 corresponding to 12, so we have 8 over 12, 5 over 7.5. Now again, our calculator is not going to handle that first one or this one very well, but we could divide it out and see if we recognize the decimal. 8 over 12 again, and the last one would be 6 over 9. And again, notice what I did. I put the smaller side length on top every time, just for consistency's sake. Now that's 7.5. We don't know about that. 8 over 12. 4 goes into 8 twice. 4 goes into 12 3 times. 5 over 7.5, not sure. Let's 8 over 12, well, we just simplified that, 2/3. 6 over 9. 3 goes into 6 twice. 3 goes into 9 3 times. Now, if you want to take a wild guess, anybody want to guess what 5 over 7.5 simplifies to? That's 2/3. Again, if you're not sure, divide it out. If you took 5 divided by 7.5, you get 0.66666, which is 2/3. Same thing here, 2/3. All right, so our corresponding angles were congruent. Now, do we have proportionality with our sides? Yeah, because all of these fractions simplify down to the same thing. Now, remember, this is your statement. You don't have to write statement of proportionality out every time, but again, I need the numbers. Okay. So that's our statement of proportionality. Now what we can do is we can do a similarity statement. So let's do our similarity statement. A similarity statement would say, hey, this shape right here, I'm going to go pentagon A, B, C, D, E is similar to, now we have to find a corresponding angle, would be F. Go right around the horn now, G, H, I, J. So F is similar, or corresponding to A, B is G, C and H, D and I, E and J. That's our similarity statement. Now let's find our magnitude. We already have it. Our magnitude is 2/3 or 3/2, depending upon which way you're going. Remember, from the big guy to the small guy, my scale factor would be 2/3. Multiplying by a number between 0 and 1, like 2/3 is, gives you a smaller number. So 12 times 2/3 is 8. 7.5 times 2/3 is 5. 12 times 2/3 is 8 again. So on and so forth. Now backwards, going from the small guy to the big guy, I'm getting bigger, so my scale factor would be 3/2. Okay? Because remember, 3/2 is 1.5, so everything here is 1.5 times bigger than the little guy. Not the angles, though. The angles stay the same. All right, so that's what we're doing today. All right, now, what we're also going to do is we're going to use the fact that if we know shapes are similar, we have that statement of proportionality. So, hey, here's my similarity statement right here. Quadrilateral ABCD is similar to quadrilateral EFGH. They're not squares, rectangles, or trapezoids or anything like that. They're just quadrilaterals. We want to find X, Y, and Z. First thing we need to do when we're doing these types of problems is find two corresponding sides that we know. Right. So if I look at 6, its corresponding side is X. I don't know both of them. Z, 14. 4y. 5 and 10. Bingo. There we go. So what we're going to do, we're going to start our statement of proportionality with 5 over 10. Okay. Now notice I put the smaller side on top. Now the next one, let's do x. What side's corresponding to x? Well, 6 is. Now 6 is on the smaller side, so when I go to set this up, 6 is going to go up top, x is going in the denominator. Now right away here, guys, we should look at this and say, I know how to solve that. To solve this guy, we just do our cross multiplication. Now, if you think a little bit, how could I make this a little bit easier? Well, yeah, 5/10 simplifies to a half. So if we wanted to use a half here instead, we could do that. Now, I'm going to do the work as is. So I'm going to cross multiply. 5 times x is 5x. 10 times 6 is 60. So we divide by 5, and 60 divided by 5 is 12. Now I'm going to show you a way we can actually simplify that process here in a second. So x is 12. All right, let's go find y now. Let's go find y. I'm going to keep that 5 over 10. I'm going to keep that 5 over 10. Now what we need to do is find y. Okay, here's y right here. What side's corresponding to y? Well, 4 is. Now 4 is on the smaller shape, so that's got to go up top just like the 5 was on the smaller shape. And then the y goes in the denominator. Cross multiply, 5y equals 4 times 10, which is 40. Divide both sides by 5. Y is 8. So there's another answer. So we found y is 8. Okay. Now what we can look at is if we do this again for z. But let's start thinking a little bit here. This is going to make this a lot easier. What's your scale factor in this problem? It was 5 over 10, right? Well, 5 over 10 simplifies to 1/2, or 2 over 1, which is 2. Okay. So if we look at this, my scale factor was 1/2 or 2. Going from 6 to 12, I just multiplied by 2. Going from 4 to 8, my scale factor was 2. So I just multiplied by 2. Going from 5 to 10 times 2. So what number here times 2 would give me 14. Or think backwards, the scale factor going backwards would be 1/2. Well, 14 times 1/2 would give us 7 here. So z is 7. So there's your 3 answers. Now you can use the scale factor. The reason I show you the proportions is because if I let you guys, and I keep telling you to use the scale factor, you got a 50-50 chance, and for some reason people are less than 50-50 on guessing right on here. Let's do another one of these. Now notice what they said. They said figure 1 is similar to figure 2. That was me being lazy and not wanting to label every vertex. Find the missing side length and the magnitude. Which if we find the magnitude right away might make things easier for us. Alright, let's go ahead and look. We need to find 2 corresponding sides that we know. Alright, start here. V6, no. 15Z, no. 10W, no. 12Y, no. X, 8, no. 6, 4, bingo. There it is. So what we have is we have our proportion that we can start setting up now. We would have 4 over 6. Now again, I put the smaller shape on top. So let's find x first. Over. What side's corresponding to x? Well, that would be 8. Now which one goes on top? I always say the smaller side on top. 8 over x. Now again, we cross multiply. 4 times x. Now remember, instead of 4, 6, what could we use? Well, if you look at 4, 6, you simplify that, you have a scale factor of 2/3 or 3/2. So the big guy to the small guy, your scale factor is 2/3. The other way, it's 3/2, because it's 1.5 times bigger. So you can use that, just multiply if you want, but I'm going to set it up. 4x equals 48. Divide by 4, x is 12. So that's what x is. X is 12. Now next one. Let's find y. Now I'm going to stick with that 4, 6. I'm going to stick with that guy. And again, I could simplify that to 2/3 and if I wanted to. Over. Here's y. Y is corresponding to 12. So we're going to do y goes on top because it's on the smaller shape over 12. Cross multiply, 6y equals 4 times 12, which is 48. Divide by 6. Y is 8. We could go through the same process here to find w and z. So let's move on. Now, Bookwork. Let's get started with the bookwork right here, and then when I finish up here, you can continue. If two triangles are congruent, they must be similar. Well, these guys were similar, but are they exactly the same? No, they are not. So that, if they are congruent, if they're exactly the same, are they going to be similar? That's yes. Now, question number 2 says, hey, if two triangles are similar, do they have to be congruent? If we look at these guys, these two were similar, but are they congruent? No, they're not. So that would be no. Okay, move on. Now, exercises 3 through 6, triangle ABC is, there's our symbol for that again, similar to triangle LMN. List all pairs of congruent angles. So let's go down here. Number 3, angle A is congruent to angle L because they're in corresponding positions. Angle B is congruent to angle M. And angle C is congruent to angle N. All right, so there is our congruent angles listed out. Now 4, let's go ahead and write the ratios of corresponding sides in the statement of proportionality. Okay. So I'm going to start down here with that 15. Its corresponding side is 20. We have 15 over 20. Equals, let's go around the horn now, 21 over 28. Now notice I keep putting the smaller side lengths up top. Equals 27 over x. There's our statement of proportionality. Now we also could have done that with the segment names, meaning we could have taken LN over AC, so on and so forth. Okay, but I didn't want to do that. That's the thing. So there's our statement of proportionality. Now find the scale factor. We already more or less have it. We need to take that 15/20 or that 21 over 28, simplify that. 5 goes into that 3 times, 5 goes into that 4 times. So your scale factor is 3/4 or 4/3. Okay, so you have either one of those. Now remember, big to small it would be 3/4, small to big it would be 4/3. 6, find the value of x. We have it right here, or with that 15 over 20. So that's what I'm going to use. So I'm going to take this guy right here and use that. So I'm going to go 27 over x equals 15 over 20. Cross multiply, we have 15x equals 540. Divide by 15, and you get x equals 36, I believe. Check your calculator. Now, next one, are the two rectangles shown at the right similar? Check your corresponding angles. Are they all congruent? You betcha. So we need to check the second part, are the corresponding sides proportional? Well, let's look. 4 would be corresponding to 10. So we're going to look at 4 over 10. Should be equal to 7 over 15 if they are similar. Well, simplify them. That's 2/5. Simplify 7 over 15. That doesn't simplify it down. That's just 7/15. Are these two fractions equal? Well, no, they're not. Now, if you're not sure, watch this. 7 times 5 is 35. That should equal 2 times 15, which is 30, and it's not. So are they similar? No. Now, explain your reasoning. We're done. There's your explanation right there. That's all you need, and no. Right? Now, 8 through 9. 8 and 9, guys, you don't have side lengths here, but what you're going to do is you're going to list all pairs of congruent angles. So angle P is congruent to angle D, go around the horn. And then you're going to write the ratios of corresponding side lengths in a statement of proportionality. To do that, you would just look at this. PQ and DE are corresponding. So I would say, hey, segment DE over segment PQ equals, let's go DF over PR. And finish it out, EF over QR. There's a statement of proportionality without actually having numbers. Now that's what you're going to do on number 9. You're going to do the same thing, except you'll have 3. You'll have 5 of these because these are pentagons. You'll have 5 of these because it's pentagons. All right, so that's good for the video. Your homework assignment will be 7.2. You're going to do only 1 through 25. Again, I shortened up the assignment because you're going to have to show some work on that. Now, if you have questions, please come in during seminar, or you can go back through, rewatch the video, and get your questions answered that way. Well, good luck, and see you in seminar if you'd like to check or have questions.